Hello again, and welcome to the modeling part of CAFE DSS tool. Here, we're going to talk about process-based model and how do they fit into the DSS, what do we need to run them, and what's the potential of each model so we can give you recommendations in order to choose one of them. Process-based models in CAFE are the software that calculates the ecosystem services. Why? Because they calculate water, carbon, and or nitrogen ecosystem or biome dynamics. They are usually physically based, and we are using them to quantify the variables related to the ecosystem services. When we are running a process-based model, we need to know the spatial complexity of our study site. If we have different species, different physical structure, different soil, topography, or we are in a place where everything is more or less the same, like it could be a forest plantation, for instance. We also need to know in advance which are the questions we want to answer, and of course, which data do we have to run the model. The required data usually are referred to meteorology, usually daily time series of temperature, precipitation, relative humidity, and solar radiation. Of course, we will need a digital terrain model, soil characteristics, usually texture, depth, and some hydraulic properties, and of course, vegetation description. Which species do we have, and what's the physical structure, like tree density, forest cover, and so on. If we're going to use Biome BDC MUSO, we have to know it is a non-distributed model. So we can we are going to calculate the average biome, or we know we have a very homogeneous biome that we are going to work with. But we are not going to get differences between species because it is, on the one hand, non-distributed in the space, but also monospecific. So it averages the forest behavior. It calculates water, carbon, and nitrogen in soil in the different parts of the plant. So it can calculate all the considered goods and services into our DSS tool. So what can I answer with this model? This model is really good to answer how much in terms of forest plantation. So which one will be my tree density, my optimum tree density. The thinning intensity, of course, how much, and the temporal scheme. When do we have to do the next thinning and the next one? And we say it is highly recommended for forest plantation or any homogeneous forest you want to work with. If we choose RHESSys, we must say it is spatially distributed. What does it mean? I can model what's going on in one pixel and in the next one and in the next one. And the pixels are communicated among them. So I can simulate or I can work with a landscape. It calculates water, carbon, and nitrogen in soil in the different parts of the plant, like Biome BDC. So I can include here all considered goods and services. It is also considered a heterogeneous forest biophysical structure, so it means different species and different vertical stratum. So I can answer the 4 questions here: how much, where, when, and how. If I'm choosing TETIS, it is also distributed, so I can still stay with a heterogeneous landscape, but it only calculates water dynamics. It has heterogeneous forest biophysical structure, but among pixels, not within the same pixel. Last model, RHESSys, within the same pixel, I could include different species. Here is from pixel to pixel. With this model, with TETIS, I can answer thinning intensity and where do I have to do the thinning. This model is highly recommended for short-term planning, which is mainly looking at water provisioning, because in terms of water, in terms of stream flow, in terms of water dynamics, it is the best of the 3 of them. And thank you.